Today we are going to do some examples of proving triangle. Excuse me. Already tongue-tied. That's not a good sign. But proving triangles in the coordinate plane. All right. So here's our first example. We have given that the triangle with vertices 4, -1, 5, 6, and 1, 3. Show that triangle is an isosceles right triangle. So first of all, what does that mean? For it to be an isosceles right triangle, that means two sides have to be congruent and we have to have a right angle in there. So the first thing I want to show is that right angle. I am going to, it's kind of a cheat because I have this picture drawn here, and I'm going to just kind of eyeball it, and I kind of feel like this side is perpendicular to this side. So that's the side that I'm going to check first. And if it works out, awesome. And if it doesn't, then I'll check another side because I have to check all of them to be fair. So I'm going to check this side first. These two sides to see if they intersect at a perpendicular angle. And I'm going to do that by looking at their slopes. And remember, if they have perpendicular slopes, that means that it's a right angle. So I'll look at from A to C and see what that slope is. And so from, let's say, slope from A to C is equal to, and it doesn't matter which one I choose to go first to be my first point or my second point. I'll choose A to be my first point and C to be my second point. And so slope is y2 minus y1 over x2 minus x1. So y2 is 3, y1 is -1, so that's a minus a -1, so it turns to a +1. And then my y2 is 1, and my y1 is x1 is 4, so that's -4. So I have 4 over 3. 4 is negative, so it's a -4/3. All right, so now I'll check the slope of B to C, and just because of the way I named it, this will be my first point. Then C is still my second point, so that's y2 again. So that's 3 minus 6, and 1 minus 5, and I get 3 minus 6 is -3, and 1 minus 5 is -4. Negative divided by negative turns into positive. So these are reciprocals. So far this is a right angle, so this definitely is a right angle. So far it's a right triangle. We know that. Now we have to show that they're isosceles. And isosceles means that they have equal lengths. So that means that two sides are equal. All right, so just from my knowledge of right angles, I know that this side of right triangles, I know that this side, because it's directly across from the right, has to be the longest side. So it is most likely, well, if it's the longest side, then it's not going to be one of those equal sides. So again, I'm going to look at these two sides. I'm going to find the use of distance formula for these two sides to see if they are in fact equal. So I will use my distance formula. And again, I'll use the exact same first point and second point. So this is for AC. We'll do AC first. So the square root of x2. So my x2 is 1 minus my x1, which is 4, squared, plus my my y2, which is 3, minus my y1, which is -1, so that's going to be a +1. Oops. I have 1 minus 3, 1 minus 4, which is -3, squared, plus 4, squared, and that's equal to 9 plus 16, which is the square root of 25, and the square root of 25 is 5. All right, let's do the other side to see if it's also 5. So again, I'll use the same convention. So this is my first point, my second point. So that is my x2 is 1 minus my x1, which is 5. And as you notice, it's probably the same thing for my slopes that I have here. So here's my slope here. Just drop it right down here. And then again for my y2 is 3 minus my y1 is 6 squared. Most likely going to get the exact same thing, right? So I get negative 4 squared plus negative 3 squared, which is 16 plus 9, which is the square root of 25, which is 5. So we have just shown, we just proved that this is in fact an isosceles right triangle. All right, let's look at another one. It says prove the polygon with coordinates 1, 1, 4, 5, and 4, 1 is a right triangle. So this time I have to draw it, which means that it's going to be really sloppy, and I apologize. So here's my 1, 1. A is at 1, 1. B is at 4, 5. Is that 4? I think that's 4. Hopefully that's 4. C is at 4, 1. So that's a, oh, okay, it kind of looks like a right angle right there. So I'll do this side compared to this side. So that is, those are the ones we're going to check first. So I want to find the slope of the segment from B to C, and then the slope from A to C. Okay, so let's do B to C first. So slope of B to C is equal to, let's make C my second point. So y2, which is 1, minus y1, which is 5 for my B, over x2, which is 4, minus x1, which is 4. Oh, I can already automatically see that this is 0 in the bottom, right? So that's going to give me 0. So the only way they're going to be perpendicular, we'll go ahead and do this, is negative 4, but that's just equal to 0, is if AC is undefined. And it looks like it because it does look like it's a vertical line. So now we'll do from A to C, using the exact same naming convention. So A is my first point, C is my second point. So C, we have 4. Oops, no, that's not my y value. My y value is 1. Sorry about that. So that's 1 minus 1. Oh, it already worked out, right? We already get 0 up top. We know we can't divide by 0. It's undefined. But let's go ahead and continue on. And then 4 minus 1, which is 3. So we got undefined and 0. So when I have undefined and 0, those two are perpendicular by definition because it's a vertical line and a horizontal line. And so vertical lines and horizontal lines are in fact perpendicular to each other. So this is a right angle. So it checks out, it works out. And I hope that this helps.